Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. As we have developed the interface for LCD display, and we have also interfaced 8 LEDs with microcontroller using ULN2803 Darlington driver. Before developing a program for all these LEDs, it is better to test the LEDs manually without microcontroller. First, we'll remove the microcontroller from the embedded system and we'll test all 8 LEDs without microcontroller. After testing all these LEDs, we'll insert the microcontroller again in our prototype and we'll write programs for all these 8 LEDs. So first, I'll remove the microcontroller from the prototype. Now I'll connect the power supply jumper to energize LED circuit. Here I have selected the power supply jumper for these 8 LED circuits. Now we'll test all 8 LEDs manually. For this we'll use a piece of wire. We'll use this jumper wire to test all 8 LEDs. Here we can find pin number 32 of microcontroller is 5 volt. So I'll connect one end of jumper wire with 5 volt and I'll test all LEDs one by one. Here I have connected the one end of jumper wire with 5 volt. Now I'll select the port B one by one and I'll test the LEDs. For this, first we will energize our prototype. First I'll select port B7. Okay, the LED connected with port B7 is switched on. Now we'll check rest of the LEDs one by one. Okay, we have checked that all LEDs are working properly. Now we'll insert again the microcontroller into the prototype. Now we'll develop a program to switch on and switch off all these LEDs simultaneously with a delay of 0.5 seconds. To develop this program, we'll use mikroC compiler. Now we'll close all open projects. We'll go for project, close project. Again we'll go for project, new project, standard project. Next, we'll assign a name to our new project, that is port B underscore blink project. And here we have the path for the folder to which we will save our project, that is port B blink project. The microcontroller is PIC16F877A. Device clock, that is frequency of the crystal, is 10 MHz in our case. Okay, next, add file to the project. No, we don't have any file to add the project, so we'll go for finish. Okay, here we have our program window starting with void main. So first we'll add some comments and assignments to our program. For this we will make some space in our program by entering the void main. Here we will assign the comments. Port B blink program, dated 18/08/2018. Now we'll add some assignments, that is define using hash, LED PRT LED port, port B, now in main we will initialize the direction of port B, that is output port. So we'll set the tri-states of port B as output. So we'll write trace B equals to 0 B 0 0 0 0 0 0 0 0. Here we have assigned the direction to the port B, that all 8 pins are output. Here we have assigned the value in binary format. We can also assign this value as decimal number like 0. Now we start our while loop from do. And while 1. We'll write our program between these two braces. We'll start our program, that is LED PRT equals to 255. Here we have assigned the value as decimal number. Now delay underscore millisecond, that is 500. It means that a delay of 500 millisecond, it means 0.5 second. Now LED underscore PRT equals to 0. Again we'll copy the delay and we'll paste the delay here. 255 means all ports will be high and 0 means all ports will be low. Now we'll compile the program and we'll test our program. Okay, save. Here we can see our program is compiled successfully and there is no error in our program. Now we'll download the hex file in Microcontroller and we'll test the program in our prototype. Now we'll connect Picket3 programmer with programming port of our prototype. Okay. Now I'll run the Picket3 programmer software. Here we can find the controller is detected. PIC16F877A microcontroller is here. To download the program to the microcontroller, we will go to the file, import hex. Here we have two hex files. LED Blink hex file is the previous program which we have developed in our previous session. And we can find port B Blink project hex file, the project which we have developed recently. We'll open the hex file. Here we can find hex file is successfully imported. Now we'll download the program to the microcontroller by pressing the right button. Okay, programming successful. Now we'll run our prototype and we'll test our program. Okay, our program is working properly. All 8 LEDs are blinking with a delay of 0.5 second. Now we'll write another program that is a counter to run on these LEDs. Here we have our port B Blink project which we have developed recently. Now we'll go to the project and close project. Again we will develop a new project, the standard project. Next, LED counter. Project folder path will remain the same and controller is PIC16F877A. Device clock, that is frequency of the crystal, is 10 MHz in our case. Okay, next. Finish. Here we have a new program window. We'll add some remarks and assignments in our program and we'll make some room for it. LED counter program. Now we'll add port assignment. By hash define LED port B. Now we'll add variable assignments. We'll add a variable that is unsigned character. Unsigned character, and variable name is counter, and the initialization value is 0. Here we have used a variable type that is character because we have to deal with port B, and port B has 8-bit length, that is a byte, and character variable represents the value of byte. Okay. Now we'll write the main program. And here we have our main program. We'll write our while loop in main program, that is do and while 1. Now we'll write program between do and while. Before while loop, we'll set the try state for B as output, that is trace B equals to 0. Here we have declared that all port B will be output port. Now in while loop, we'll move the value of counter to the port B, and we have assigned the name LED port to port B, so we'll move the value of counter to LED port. So we'll write LED port equals to counter, and here we'll assign a delay for increment, that is delay underscore millisecond 500. It means that the delay of 500 millisecond, that is 0.5 second. Now we'll increment the counter variable, counter plus plus, and that's all. Our program is completed now, and now we'll compile our program. Okay, we'll compile the program. First we will save our program. Here we can see our program is compiled successfully and hex file is developed. Now we'll download the hex file to the microcontroller. Again, I'll connect PicKit3 programmer to the programming port of prototype. Okay, now we'll run the program for PicKit3 programmer, and here we can find PIC16F877A microcontroller is detected. We'll go to the file, import hex, and we'll load the hex file, that is LED counter. Okay, hex file successfully imported. Now we'll download the program to the microcontroller by pressing the right button. Okay, programming successful. Now we'll power up the prototype and we'll observe the program which we have developed recently. Okay, here we can find the counter is running on LEDs and the increment delay is 0.5 seconds. Now we'll connect 4 switches with our microcontroller and we'll write a program to start, stop and reset the counter using 3 switches. Here we can see we have 4 push buttons in our schematic diagram, and these digital inputs, that is digital input 0, digital input 1, digital input 2 and digital input 3, these all 4 switches are connected to port RD4, RD5, RD6 and RD7. So we'll connect these switches in our prototype and we'll develop our next programs using these switches.